today's world, communication plays an important role. Satellites are used for effective communication. Apart from communication, satellites are used for various purposes ranging from analysis of weather conditions in a region, live transmission of cricket matches through television, exploration of minerals from the earth, and for geographical purposes. Satellites used for various purposes are artificial satellites. In a broader sense, there are two categories of artificial satellites, namely geosynchronous and sun-synchronous satellites. First, you will learn about geosynchronous satellites. Earlier, you learned that the speed of an Earth satellite in its orbit is denoted by the expression v is equal to 2 pi into Re plus h divided by t, where Re is the radius of the Earth, h is the height of the satellite from the Earth's surface, and t is the time taken by the satellite to complete one revolution around the Earth, which is referred to as its time period. Let this be equation 1. The speed of a satellite in its orbit can also be obtained using the relation v is equal to the square root of gme divided by Re plus h, where me is the mass of the Earth and g is the universal gravitational constant. Let this be equation 2. Equating expressions 1 and 2 and simplifying, you get the expression for h, as shown in equation 3. Knowing the data for the mass of the Earth, its radius and universal gravitational constant, you can estimate the height of the satellite for which the period of revolution is 24 hours. This is done by substituting the corresponding values in equation 3 and simplifying as shown. Thus, a satellite whose height from the surface of the Earth is about 35,850 kilometers has a period of revolution equal to that of the period of rotation of the Earth. If the orbit of the satellite is in the equatorial plane of the Earth, then the satellite appears to be stationary relative to a position on the surface of the Earth. Such satellites are called geostationary satellites or geosynchronous satellites, as their motion in their orbit is synchronized with the rotation of the Earth. Generally, this type of satellite is used for telecommunications and mass communications. The Indian National Satellite System, generally referred to as INSAT, is a series of geostationary satellites set up by Indian Space Research Organisation (ISRO) to cater the meteorological, telecommunications and broadcasting needs of the country. Now, you will learn about the second type of artificial satellite, a sun-synchronous satellite, also referred to as a polar satellite. The altitude of a polar satellite is lower than that of a geostationary satellite. That is, in the range of 700 to 1,700 kilometers. Accordingly, the time period of such a satellite is of the order of a few hours. The orbit of these satellites is such that the satellite moves in a plane that is near normal to the equatorial plane, moving closely to the poles of the Earth for every revolution, while the Earth rotates in west to east direction. Why are these planets called sun-synchronous? As you know, the local time at a given place on the Earth depends on the longitude of the place. With the rotation of the Earth, the local time at a given place changes with the relative position of the Sun. The orbit of a sun-synchronous satellite is designed in such a way that the angle between the plane of the orbit and the line joining the Earth and the Sun are fixed. This maintains consistency in the lightning conditions of a given place. When a satellite revolves around the Earth, successive north-south passes are displaced the same distance as the Earth rotates during one orbital period of the satellite. As a result, the satellite covers the given place at the same local sun time daily. Thus, the motion of the satellite is synchronized with the local sun time at the given place. Hence, these types of satellites are called sun-synchronous satellites. As they cover the polar regions for every revolution, these satellites are referred to as polar satellites. As the altitude of a polar satellite is less, a camera fixed to the satellite can scan only a small strip of the Earth in one revolution. For the next revolution, as the Earth rotates on its axis, the adjacent strip of the Earth is scanned. Thus, in a single day, the whole of the Earth is scanned in a series of strips. Indian Remote Sensing Satellites, generally referred to as IRS, which are used for remote sensing applications, environmental studies, weather analysis, forecasting, and similar applications, are examples of polar satellites. Artificial satellites are generally unmanned. At times, cosmonauts are sent along with satellites into space to conduct certain studies. In space, they feel zero gravity or weightlessness. The weight of a body is the force experienced by the body due to the gravitational pull of the Earth. A spring balance that measures the weight of a body works on the principle of extension of the spring. Under the action of the weight of the body attached to the balance, which is fixed to a rigid support. While measuring the weight of the body attached to the balance, the body is pulled downwards due to the Earth's gravity. It, in turn, exerts the same force on the spring downwards, causing its extension. This is indicated in the reading of the balance. If the balance is not suspended to the rigid support and is allowed to fall freely, then both the body and the spring balance fall down with acceleration due to gravity. In this case, the force exerted on the body by the balance is 0. Hence, the stretching of the spring is 0. Thus, the spring balance reads 0 weight of the body. This situation is the weightlessness of the body. Thus, we can say that a body experiences 0 gravity or weightlessness in a free fall. In the case of a satellite orbiting the Earth, it is similar to any other freely falling body. But it has very high velocity in a tangential direction of its orbit, due to which it misses the Earth as it falls. Thus, every part of the satellite is in a state of free fall, and it is subjected to acceleration due to gravity in that position. Hence, cosmonauts in manned satellites experience weightlessness.